This is lesson 6.2 in your textbook, Solving Systems by Substitution, and this begins on page 390. What I'd like you to do is to take notes and write down all of the examples that I'm doing along with me in your journals. Make sure that you pause this at any time if I get ahead of you. But before we get started, I just want to review what it means to solve a system. And I'm just going to make up two random linear equations. And if we were to solve this system, what it's really meaning is to find the ordered pair, the x and the y value, that would make both of these equations true at the same time. So the first way that we learned how to do this was by graphing them. And you guys found the other day when we graphed these two equations, and I'm just doing a brief sketch, we found that if the lines intersect in one point, that point of intersection was our solution. That was our x, y value, that when you plugged into both equations, it would make both equations work at the same time. So as a review, that's what we are still looking for. But now we're going to learn another technique, and by the time we learn 3 or 4 of these different techniques, you'll definitely have a favorite or one that you think works best. But it's important that you know how to do all of the methods, because you never know what form the equations will be given to you in. So here's going to be our first example. And again, this is solving by substitution method. And to solve by substitution, what you do is you find one of the equations that is already solved for x or y. So in this case, both equations are solved for y. So this is saying that y is equal to x plus 3. So whenever two things are equal, you can interchange them. So if y equals x plus 3, we're going to take this value that they're saying y is, and we're going to substitute it into the other equation for y. So if y equals x plus 3, we're going to plug that in here and get the equation x plus 3 equals 2x plus 5. In other words, we just set these two equations equal to each other. And now doing a little bit of algebra, we can solve this to get a solution of x equals -2. So what we just found was half of our solution. Because remember, a solution is the ordered pair that makes both true. We found the x value. So now to find the y value that goes along with it, you can go back to your given two equations and you can choose whichever one you want. I'm going to choose the top one. Y is equal to whatever x is plus 3. Y equals x plus 3, and in this case x is -2, so y comes out to be 1, and there's your solution. Now let's see if this works. When you plug -2 in for x, -2 plus 3 is 1, so that one worked. And when you plug -2 in for x, 2 times -2 is -4, plus 5 is 1. That one works. And again, if you were to graph these two lines, they would intersect at the point -2, 1. Okay, so that's substitution method, and that's probably the easiest example of it. And quite honestly, if the equations are given to you this simply, already solved for y, graphing might be the easiest way, because you can just plug those into your graphing calculator and find the intersection. But some of you don't like to graph, and so substitution certainly works. Okay, let's look at a harder example. So x equals 2y minus 4, and x plus 8y equals 16. And this is a better example of why you might want to use substitution. And the reason is, do you see that neither of these is already solved for y? So to graph them, we would have to do quite a lot of work. We would have to solve for y and put it into slope-intercept form, or in this case, we could try to find the x and y intercept. But it's not really set up really nicely to just graph, But what it is set up nicely for is substitution, because the rule for substitution is you need to have at least one of the equations solved for a variable. So this first equation, we see that x is equal to 2y minus 4. So we're going to take this value that they're saying x is, and we're substituting it in place of that variable, x, in the second equation. So this is where the name substitution comes in. So then we write this equation by making the substitution. So we get 2y minus 4, which is x, plus 8y equals 16. Then we add like terms, because on the same side of the equal sign we've got some like terms. So 2y plus 8y is 10y. And in one step here I'm going to add 4 to both sides just because of time to get 20. Divide by 10 and get y equals 2. So just like before, we now have half of our solution. We have our y value. So just like before, we substitute y back into either equation and figure out what x is. Well, the first equation is going to be the easiest to do. If y is 2, 2 times 2 is 4, 4 minus 4 is 0, and we've got our solution. Now it's always good to go back and check. When x is 0, if y is 2, does this work? 2 times 2 minus 4 is 0. Yes, it does. If x is 0 and y is 2, is 8 times 2 is 16. That works. Okay, so there's 2 examples. Let's take a look at another example. What happens if neither equation is solved for the variable? Like 2x plus y equals negative 4 and x plus y equals negative 7. So to solve by substitution, we first have to solve one of these equations for x or for y. So it's really up to you. I'm going to do the bottom equation and I'm going to solve it for y. So I just subtract x from both sides and I've got that here. Now I'm going to take what y equals and I'm going to substitute it up here for y. So I'm going to rewrite this top equation. I have 2x plus, in place of y, I'm writing negative 7 minus x equals negative 4. So this top equation said 2x plus y equals negative 4. So 2x plus, do you see that this is the value of y that we found in the second equation? Okay, so once this is set up, we just solve 2x minus 1x is just x. And then you're adding a negative 7, so if I add a positive 7 to both sides, I get 3. So once again, that's my x value of our solution. And I'm going to pick the simplest equation I can down here. Actually, we can use this form. If x is 3, negative 7 minus 3 more is negative 10. And it's always good to go back and check your x and y values. But because of time, I'll let you do that when the video is over. Okay, so those were 3 really basic, really good examples of substitution method, but there's a few little tricks. So I want to do one more, because you have to be aware that sometimes when you substitute, you are going to have to use the distributive property. And this example will illustrate that. Okay, so as you can see, neither of these are already solved for one of the variables, so you always want to, or at least I, always try to find the equation that's the easiest to solve. What I mean by easiest is I mean the fewest steps. So right away it jumps out to me that if I solve this one for y, I'm not going to have to do any dividing. I'm not going to have to get rid of a coefficient. So to solve this for y, I would get y equals 8, and then you add 2x to both sides. So that's probably the easiest solution. Now I'm going to take this value of y, so y equals 8 plus 2x, and we're going to plug it down here in place of the y. Now notice that this is not just one y, this is 2y. So when we make this substitution, we're going to have to realize that this y value of 8 plus 2x has to be doubled. So it's going to look like this. We have 3x plus 2 times y, but in this case, y is 8 plus 2x. Notice how I use the parentheses there to set that substitution apart. And I also use the parentheses because we have to double this entire expression. We have to double 8 plus 2x, so that's the distributive property. So now to simplify this, we are going to distribute 2 to get this solution. Now we're going to add like terms. Subtract 16 and divide by 7. And we get, once again, the first half of our solution. So our solution is going to be the ordered pair -1 comma something. Now we can plug this -1 into either of our two original equations or the equation where we solved for y, because these two things are equivalent. So I'm going to use that one. When I put -1 in place of x, I get 8 plus -2, which is 6. Okay, so that's one of the biggest catches you have to watch out for. And real quickly before we end, I want to talk about, hopefully by now, these word problems are becoming easier for you, but systems of equations are used all the time in real life because just like our U-Haul example or buying or selling things, you often want to set up equations that model a business type scenario, and your goal is to figure out when are they equal. Because if you know when they intersect or when they're equal, you then can determine when will one scenario be higher or lower. So one cable television provider has a $60 setup fee and it's $80 per month. The second has a $160 equipment fee and is $70 per month. And both of these things are going to be expressions for your cost. Okay, so we've dealt with this all the time. The cost of the one provider is 60 plus 80 per month. The other cost is 160 plus 70 per month. And this is set up really nicely for substitution because you take what C is equal to in one, substitute it for C for the other, and you are home free. So in other words, in this scenario, you're setting both plans equal to each other. And we've done a form of this before. It's nothing new, just kind of looking at it through the systems of equations lens. Okay, this is what you need to do before tomorrow when you come into class. I need to be able to see your journal entry. I need to be able to see that you've worked out all of these problems. And then on page 394, I would like you to work out and show number 2, number 10, and number 18. So that's just a real short activity just so that I know that you have spent time watching the video and thinking about this lesson. We will do the bulk of the homework assignment tomorrow in class. Thanks.